In this video, we're going to walk you through the 2016 question that came up on stoichiometry calculations. Now, this is a half question, it's worth 25 marks, so you've got about 10 minutes to do this. And there's lots of ways you can tackle these questions. I've shown my students before a table method where you can use ratios to work out the reactant quantities in moles. But in this video, I think the best way and the easiest way to do this is to use a unit analysis. So this is how I'm going to do this in this video. I strongly suggest if you don't know what unit analysis is, that you go through my videos on the section on stoichiometry and learn how to do unit analysis conversions. Okay, so let's jump into the question. Again, it's quite a tricky one, lots of different components to it. It may take you longer than 10 minutes, so you may have to borrow some time from another question when you're doing this. But if you're good at this, if you practice lots of these, they do get easy. All right, so let's see what we're dealing with. It says a mixture of potassium nitrate and sulfur reacts according to the following balanced equation. It's already balanced for you. What I would like you to do is write this down here, write out this equation, and write in the molar ratio above the equation. Pause the video and do that now. All right, what you should have done here is you should have written out this equation, and you should have written the molar ratio here as 4 is to 5 is to 2 is to 2 is to 5. So these are the ratio. This is the ratio in which moles of substances will react in this equation. Let's read the next bit. It says one of the two reactants. So here are the reactants. These are on the left of our equation. One of these two is in stoichiometric excess, means we've got more than we need, when we have 20.2 grams of potassium nitrate and it's mixed with 24 grams of sulfur. So this here is your potassium nitrate and this here is sulfur. So we have to figure out, probably going to have to figure out which one is in excess down below. Right, let's jump into where we are starting the question. So it says, question 1, figure out which reactant is in excess. And then it asks you what mass of the reactant is unused at the end of the reaction. So first of all, to work out which of the reactants is in excess. If you are confident that you know how to do this, then go ahead, pause the video and have a go at working out which one is in excess. All right, if you're not sure how to begin this, I'm going to help you think about what conversions we need to do. Okay, the first thing that we need to do is choose one of the reactants. So either KNO3 or S. Choose one of them to work with at the start. I'm going to choose KNO3 because it's the first one. Okay, so we need to think about what conversions we need to do here. So we're starting with grams of KNO3. That's what it gave us in the question, a certain amount of grams of KNO3. The first conversion we have to do is find out how many moles is that of KNO3. So moles of KNO3, that's our first conversion. Our second conversion is then we're going to take our moles of KNO3 and we are going to figure out how many moles of the other reactant, which is sulfur, that reacts with. And finally, we're going to take that moles of sulfur and we're going to convert it to grams of sulfur. Grams of sulfur. Okay, so essentially you're doing 3 calculations here, 3 conversions to figure out for this amount of grams of KNO3, how much S would I need? I'm told how much I have. I have 22.2 grams of potassium nitrate and I have 24 grams of sulfur, but one of them is more than I need. So I need to figure out, if I start with this much potassium, how much sulfur would I need? So now that I've told you that, go ahead, pause the video if you think you can do this by yourself. Okay, if you're not sure about doing this by yourself, I'm going to show you how to set it up and convert by unit analysis. In the first conversion, we're going to go from grams of KNO3 and we're going to set up a conversion factor using unit analysis to convert to moles of KNO3. So when we're using a unit analysis, we always want to set up a fraction. And on our fraction, our numerator and our denominator will be different units, and they will be the things we want to go between. So grams of KNO3 and moles of KNO3. In this case, we're going to put grams of KNO3 on the bottom. And the reason for this is so that they cancel with those grams of KNO3. And it leaves us with the answer moles of KNO3. Remember, that's what we wanted to do in our conversion here, go from grams to moles of KNO3. Because it's the only unit left, we know we've done this correctly. So this is going to give us a certain number of moles. Sorry, this should be moles of KNO3. We can then think about the next conversion after that. So pause the video and put in the numbers here that you think you're going to need. I'm going to scroll over so you can see the quantity that we're starting with. Look what it says. We're starting with 20.2 grams of potassium nitrate. which is KNO3. So we're going to start here, 20.2 grams of KNO3. You fill in the fraction, the numbers here that relate. Grams of KNO3, but moles of KNO3. Do that now. Okay, what you should have done here is you should have done that there for every 1 mole, so 1 mole of KNO3 contains, and again, this is the molar mass in grams of KNO3. So to get the molar mass here, what you would have done is the mass of potassium is 39, plus mass of nitrogen is 14, plus 3 times 16 for the 3 oxygens. So when you add them up, you should have got 101. Now that we have this, we can do the conversion here pretty easily. It's 20.2 times by 1 over 101. When you do that, you should get 0.2 moles. 0.2. If you got that, well done. Let's look at the second conversion. Let's do grams of KNO3, sorry, moles of KNO3 to moles of S. Again, we're going to use a unit analysis to do this. If you're confident that you know how to do this, good. Now, what I will tell you is that you need to be looking at the equation that we wrote down earlier in order to do this. So that should give you a clue as to what you need to do next. Again, you're using a unit analysis if possible. Okay, pause the video and do that now. Okay, so hopefully you were able to do this. You should only be playing if you've had a go. If not, I'm going to help you set up the unit analysis. So first of all, we're beginning with moles, and we know how many it is. It's 0.2 moles of KNO3. We want to convert that to moles of sulfur. So again, you're going to set up your conversion factor fraction. And we want moles of KNO3 and moles of sulfur. That's what we're going between. So which one goes where? Pause the video and do that now. What you should have done is said moles of KNO3 is on the bottom. Mole KNO3. And the reason for that is so that they'll cancel with those ones and leave us with the only unit left is moles of sulfur, which is what we want in our answer here, because we're going from moles of KNO3 to moles of S. So we're going to have a certain amount of moles of S in our answer here. All right, so from the equation then, you should have learned that there are 4 KNO3 moles for every 5 sulfur moles. That's from our molar ratio. So we're going to do 4 down here and 5 here. Bang that into the calculator, and you should have got this 0.25 moles of sulfur. Good, so the last conversion then is going from that many moles of sulfur to grams of sulfur. You should definitely be able to do this by yourself. Pause the video, do it now. Okay, so what you should have done is 0.25 moles of S, mole of S, times by, set up your conversion factor fraction again. We're going to put mole of S on the bottom and gram of S on the top. Mole of S cancelled with mole of S, and for every 1 mole sulfur, if you go to the periodic table, you'll see its mass is 32 grams. Bang this into your calculator, and you're going to get, let's see, 8 grams. 8 grams of sulfur. Okay. What you need to do now is you need to compare the amounts you have to the amounts you needed. Okay, so we're going to write a little sentence here. What does this tell us? For this amount of grams of NO3, it reacts or requires this amount of grams of sulfur. So pause the video and write that down as a sentence. Okay, so what I would say here is 20.2 grams of KNO3 requires 8 grams of sulfur. So going back to our question, looking at what we have and what we need, I want you to classify one of them as it being in excess, because that's what we were asked. Which one is in excess? So pause the video and write down which one of them is in excess. Okay, so what I would do here is I say, okay, well, if I have 20.2 grams of KNO3, I required only 8 grams of sulfur. Now, I was told in the question that I actually have 24 grams of sulfur. I have 24 grams of sulfur. Therefore, I have way more than I need. I only need 8, and I have 24. So what would I say? I would say sulfur S is in excess. So there is my first answer that I'm getting marks for. S is in excess. So well done if you said that. Now it said, what mass, how much in grams of this reactant is unused at the end of the reaction? So from what we've just figured out here in these 3 bullet points, you should be able to tell me what mass is left over. Pause the video and work that out now. Okay, so you're only playing if you've worked out how much we have 24 grams, and we only use 8 grams. So we're taking away 8 grams, and you should have got that there are 16 grams left over. Excellent. All right, we're ready to jump into the second part of the question. It says calculate the total volume in liters, so we're converting to liters here, of gaseous products measured at STP formed in this reaction. So if I took this amount of our KNO3 at the top here, if I took this amount, how much gaseous products would I form? Now, I want to point out something to you that I always tell my students, but I don't see this very often in notes or books of other teachers. I'm not saying they're not telling you, maybe they do. I just don't see it very often in notes. What these little symbols mean. These little symbols mean they're what we call state symbols. So they tell you what state the substance is in. So S would stand for solid, L would mean liquid, and G would mean gas. There's one more as well. Sometimes you'll see AQ, which means dissolved in solution. So dissolved in water. Now, let's have a look at what it's asking us. Calculate the total volume in liters of the gaseous products. Now, the products, remember, are the things over on the right-hand side of our equation. So these three over here. And we have two gases, as you can see here, N2 and SO2. So we need the total volume produced of the two gases. So again, if you think you can have a go at this, go ahead, pause the video and have a crack at it. All right, it's always best if you're able to stay ahead of me, do it by yourself. That's always best. I'm only here to give you that bit of guidance and help you along if you need a little bit of support. That's all I'm here for. If you can do it by yourself, brilliant. Okay, let's have a look at the steps we might do if we're struggling. Okay, well, first of all, what we're going to do is we're going to need to convert from the moles of one of the reactants that we're using. Now, I'm going to take a little cheat here. I could start with grams and go to moles and find out how many moles of one of the reactants I had, but I've already done that up here. So I'm going to go ahead and use this as my starting point. I'm going to cheat here. So I'm going to say, okay, I need to go from moles of KNO3. That's the reactant I'm going to start with because I've already worked that out. Moles of KNO3. And I'm going to first go then to find out how many moles of the gaseous products. So there are two of these I need to do. So I'm going to do moles of N2, and then from there convert to liters of N2. And in a second reaction, because I need to also find the other gas product, I'm going to go from moles of KNO3 to moles of the other gas product, which is SO2. And then from there, I'm going to go to liters of SO2. So I'm going to find the liters of each gas product that was made, and then I'm going to get the total. So I'm going to add them up, the two volumes, to get the total volume of the products that were gas. So I'm going to get you guys now, you should be able to have a go at this using unit analysis, go from moles to liters for both of these and add them up. Pause the video, have a go at this. All right, you really need to be having a go at this, guys. If you're just listening and waiting for me, you're not going to learn as much. You have to be having a go at them. That's really, really important. And as more of these you can practice, the better. Okay, so again, what we're going to do is we're going to guide you through the unit analysis, setting up the unit analysis. If you're struggling, I think you should be getting the hang of this now. All right, so again, I'm going to go from moles of KNO3. Now I'm going back up here. I'm always starting with 0.2 moles of KNO3. That's how much I had at the beginning. So both of my calculations here are going to begin with 0.2 moles of KNO3. I'm going to do two of them, one for each of the gas products. Moles of KNO3. For each, this top one will do N2 first. So we're going to go from moles of KNO3 to moles of N2. So if you can, pause the video and write down moles of KNO3 and moles of N2. Decide which one is on the top, which one is on the bottom. Okay, so you should only be writing if you filled out this here. You should have done moles of KNO3 on the bottom, so they cancel with them moles of KNO3 like that. And that leaves us with moles of N2 on the top here. Okay, so that's our first conversion done. Now we're going to put in the numbers here. What numbers is this? What's the ratio? So we'll go back to our equation and compare KNO3 and N2. So using the molar ratio, pause the video and write down the numbers on the fraction now. Okay, so I'm seeing here it's 4 KNO2s to 2 N2s. So back into my equation here, I'm going to write 4 N2s to 4 KNO3s to 2 N2s. Right, so I'm going to go ahead, put that in my calculator, and that's going to give me 0.1 mole of N2. Now, for moles of N2, I now needed to go to liters of N2. So I'm going to take this, what I did over here, and I'm converting it again. This time for moles of N2, I'm going to go to liters of N2. So moles of N2 and liters of N2 decide which unit goes on the top, which unit goes on the bottom. Hopefully we did this. Moles of N2 to liters of N2. Cancel out the moles of N2 like that. And now we're putting in the numbers. How many liters of a gas is there in a mole? Pause the video and write that down. All right, so remember, it told you in the question that this was the value was at STP, and the molar volume of any gas at STP is 22.4 liters for every 1 mole. Okay, so now we are ready to go ahead and figure out what that's going to be. Put that in your calculator and get how many liters we have. Okay, so you should have got 2.24 liters of N2. That's our first gas. Now you're going to pause it. You definitely need to pause the video and do the second one now. The second gas, which is SO2. You should definitely be able to do that. It's exactly the same as what we just done. Pause the video, do it now. Okay, so the first thing you want to do is set up, I'm going to do this quickly, moles of KNO3 to moles of SO2. Cancel out them moles, and you're going to get 4 moles of KNO3 to 5 moles of SO2. That's the ratio. And when you do that, you're going to get 0.25 mole of SO2. From there, we're going to take it and we're going to go to liters of SO2. To do this, we did mole of SO2 on the bottom, liters SO2 on the top. They cancel with them. And that leaves us liters of SO2. What's the number? It's always 22.4 liters at STP for 1 mole. Put it in your calculator, and the answer you're going to get should be 5.6 liters when you do that in a calculator. So these are both our gas products. So to find out the total volume of the 2 gases at the end, you're going to add. So pause the video and add them up and get the total. Okay, total, guys. Total you should have got for gas products here was 7.84 liters. If you got that by yourself, well done. If you got it with a little bit of help, that's pretty good. If you needed a lot of help, then you need to do more of these questions, guys. You really do. Okay, next question. Last bit. What mass of solid is produced? So this is our other product. Look, there's only one of our products up here, and it's the K2O is the only solid product. It's the only one with an S. Okay, so what we're going to do is, again, we're going to go from moles of this, which we worked out earlier, so don't do it again, to moles of this, and then go to grams of this. Okay, so I'm going to go ahead and I'm going to write down what you need to do here. If you can do it without me writing it for you, pause the video and have a go at this calculation now. Okay, so a little bit of help. What we're going to do is we're going to go from moles of KNO3, which we've already calculated and used up here. Look, this is how much we want. We don't need to do it again. Okay, and we're going to go from there. We're going to go to moles of K2O, moles of K2O, and then we're going to grams of K2O. All right, so it's really helpful to think about the conversions required before you begin, just like I'm doing in pink here. It's a really good habit to get yourself into. It gives you a roadmap and a plan for where you're going. All right, so pause the video and find out what mass of K2O is produced. All right, so what we should have done here is we start with moles of KNO3. 0.2 moles of KNO3 is what we began with, KNO3, and we convert to moles of K2O. So KNO3 to mole, sorry, that should be mole of KNO3 to moles of K2O. Moles of KNO3 cancel with moles of KNO3, and from our equation, we should be able to figure out, I'm just going to show you again, pause the video and get your ratio. If you didn't know that, there it is. You should have had it written down anyway. Okay, so hopefully you can see that the ratio here is that there are 4 KNO3s for every 2 K2Os. All right, so what that gives us is it gives us 0.1 mole of K2O. That's what we're working with, 0.1 mole of K2O. We're now going to go from moles of K2O to grams of K2O. Set up your conversion fraction. We want moles and grams of K2O, but moles needs to go on the bottom Cancel out those ones, and that leaves us with grams of K2O on the top, like that. All right, so for every 1 mole, how many grams of K2O are there? Well, what's in K2O? We've got 39 times 2, there's 2 potassiums, plus our 16 for our oxygen. Go ahead, put this in your calculator now, and you're going to get final answer. Pause the video and do it if you haven't done it. 9.4 grams K2O. And that was our final answer for part 3. So quite a few conversions in there, guys. It's tricky enough that you can make it much easier for yourself by planning out your conversions first. It shouldn't take too long to do that, but it helps your thinking process and it helps keep you on track with where you're going and how you're getting on as you go through it. If you want to see the marking scheme, there it is. It might look a little bit different from the way I did it, but all your answers should be there, should be the same. Okay. All right, so if you want to pause it, I'll zoom in on the different sections and I'll scroll for you. If you want to pause it at any point and have a look at what it says here, but you should see all of the answers are the same. And in my opinion, this is the best technique to learn in any chemistry calculations. Unit analysis, powerful tool to help you work out any calculation, really. So this is the best way of doing chemistry calculations. All right, guys, that's it. Another stoichiometry calculation video down. These are things that students tend to struggle with. So if you found this helpful and you found it easy to follow and it's something that you are taking anything from it, if you could give the video a like, it might help other Leaving Cert students to find these videos. And that's what the aim of this channel is, to help as many students as we can. So if you could give it a like, guys, and I'll see you in the next one.